Hello everyone, hope you are doing very well. Today we are going to see the theory part 2 of the chapter Alcohols, Phenols and Ethers. So let's begin our today's topic NCERT chapter 7 Alcohols, Phenols and Ethers, theory part 2, and specifically we are going to cover today the NCERT section 7.2. This is disclaimer. Today's learning objective. After attending this lecture, you will be able to name the alcohols, phenols, and ethers according to the IUPAC system of nomenclature. Also, you will be able to learn common names for the important alcohols and phenols. The topics to be covered today in lecture according to the NCERT. First of all, the section 7.2, that is nomenclature. Then we will solve an example, 7.1. Then we will also solve an text question 7.3 and an NCERT Exemplar question number 9, and then we will conclude with the summary. So let's begin with the NCERT section 7.2 nomenclature. And first of all, let's look upon the nomenclature rules for alcohols particularly. So there are two types of name exist, common names and IUPAC names, right? Common names are derived from the common name of alkane or alkyl group, and then we add the word alcohol after it while writing the common names of the alcohols. For example, you can see N-ethyl alcohol and N-propyl alcohol. So what we have done, we have just write the common name of alkyl group N-ethyl and add the word alcohol to it. Similarly, N-propyl and alcohol, N-propyl alcohol. OH is representation for the presence of alcohol group or alcohol functional group in this compounds. Then, if we talk about the IUPAC name, which is as per the IUPAC nomenclature, first rule is longest carbon chain containing hydroxyl group chosen as the parent chain. So while writing the IUPAC name, you have to remember the point that in your compound, the longest carbon chain should contain OH group and it should be chosen as the parent chain of the compound. Second point, the suffix E of the alkane name. Okay, in the alkane name, the E suffix which comes after the name of the alkane. So the suffix E of the parent alkane chain is replaced by ol. Okay, so while writing the IUPAC name of alcohols, the E of the parent alkane is replaced by ol. For example, you can see we have propane, 3 carbon chain, and when hydrogen is replaced by the hydroxyl group, which is for the alcohol, you will get a propanol. So you are writing the IUPAC name of this compound as propanol. So E is replaced. E of the parent alkane propane is replaced by ol for the OH group for the representation of alcohol. Third major point to remember is numbering done to give the lowest possible number to the carbon which is attached with the hydroxyl group. So when you are doing the numbering in your compound, you have to select the parent chain and then you have to numbering or you have to give the numbers to the carbon in the parent chain. Okay, the carbon which is attaching with the hydroxyl group in our parent chain should contain a lowest possible number. Okay, so while numbering this, you have to remember that you have to give a lowest possible number to the carbon which is attaching with the hydroxyl group in our parent chain. For example, we have these compounds here which are depicting the numbering of the carbons, and you can see the B1, the B structure is the preferable one because it is having 1 and 2 as the numbering of the carbon which is attaching with the hydroxyl group. Whereas in the structure A, the carbon which is attaching with hydroxyl group, OH group, is having the numbering 3 and 2, which is comparatively larger numbers, right? So you can also learn it in the way that 1 plus 2 is 3 and 3 plus 2 is 5. So the sum of the numbers is 5 in the structure A, the sum of the numbers is 3 in the structure B. So B structure is giving us a smaller number, so that means that numbering given in the B structure is the preferable one, where the carbon attaching with OH group is having lowest possible number. Continuing on this topic, let's talk about the polyhydric alcohols. What are polyhydric alcohols? Where there is more than one hydroxyl or OH group present in our compound. In that case, while the naming of that compounds, suffixes like diol or triol are used. If we have 2 OH group, then diol. If we have 3 OH group, then triol, and so on. The E, this is important to note. This is important to note that the E of the parent alkane is retained before the suffix. What does it mean? It does mean that the E which was replaced by the ol when you are writing the name of a compound where only one OH group is present. Here, in the polyhydric alcohol's case, the E of the parent alkane name is remain there before the suffix. You don't have to replace it by diol or triol suffixes. Let's see the example. So we will see the example. The positions of OH group are indicating by numbers. Okay. And as I said that in the polyhydric alcohols, we have more than one OH group. And that carbon which is attaching with the OH group, that carbon is given some number. Okay. So the position of OH group are indicated by numbers, by the numbering done in the parent chain. You can see this example of propane 1,2-diol. The 1 and 2 is the numbers which is depicting the positions of OH groups in this alcohol. Okay, so the name will be propane 1,2-diol. 1, 2 both, 1 and 2 both the numbers we have to write while the naming, because both are showing the different positions of OH group, right? And we use the suffix diol because 2 hydroxy groups are present in our compound. A 3 carbon chain having 2 hydroxy group, so what propane 1,2-diol. Note here that the E of the propane, the parent alkane is propane, and the E of this alkane is retained is as it is before the suffix. We don't have to replace it. Next, we talk about the cyclic alcohols. While naming the cyclic alcohols, the prefix cyclo is used. Prefix means you have to put a prefix which is cyclo before the name of the alcohol for the cyclic alcohol. You can see in these structures, one is hexane 1,2-diol, which is a straight chain alcohol, polyhydric alcohol containing 2 hydroxy group, and the positions of the hydroxy group OH group are indicated by the numbers 1 and 2. The lowest possible number is given to the carbon. Similarly, for the cyclic alcohols, we are using a prefix cyclo. Other than that, every rule is same. Cyclohexane 1,2-diol. In this cyclohexane structure, at the first and the second carbon, we have OH group attached. So the name will be cyclohexane 1,2-diol. Here also you can observe in these two names of the structures of the alcohols that they are polyhydric alcohol. So the E of the parent alkane is retained before the suffix. Let's see some examples of IUPAC nomenclature. So, for understanding the IUPAC name format, which we have to use generally in while naming the alcohols, the general IUPAC name format is: first is prefix or prefixes. If you have more than one substituent present in your compound, so first is the prefixes or prefix, then comes the word root, then comes primary suffix, and then the secondary suffix. Now, what are these? What is each word or each, part represent here? What is prefix? What is word root? What is primary suffix? And what is secondary suffix? We will understand it by seeing this example. This is the example. We have 4 carbon parent chain. You can see we are done the numbering, and the lowest possible number is given to the carbon which is attaching with OH group, that is 2. So at the second carbon we have OH, and at the third carbon we have methyl group as a substituent. So you can name this compound as 3-methyl butane 2-ol. Now here you have to understand, let's break the name. 3-methyl. 3-methyl means third position or third carbon attaching with the methyl substituent. Now this is a prefix which you have to place it, or which you have to place before the starting of a main name, right? So prefix is 3-methyl, which represents the substituent present in your parent chain or in your compound, 3-methyl. Then comes the but. But is considered as word root because it represents the parent chain number of carbon. We have 4 number of carbon present in our parent chain, which is represented by but. Then comes the primary suffix, which is ane. Now from this ane, e is replaced by the secondary suffix 2-ol. And 2-ol is representing that at second carbon, the OH group is attached. So this is how you can break the name of a compound of alcohol in various parts, or you can say 4 parts: prefix, word root, primary suffix, and secondary suffix. Let's see a table 7.1 showing the common and IUPAC names of some alcohols. So this is the table having compound column, common name, and IUPAC name column. First compound is the simplest alcohol, methanol. Common name is methyl alcohol. So remember, we have said that firstly you have to write the parent, or you have to write the alkyl group name and then add the alcohol to it for writing the common name of alcohol. But for IUPAC name, you have to write it properly, like alkane, primary alkane, or you can say parent alkane, and then E will be replaced by ol. Okay. So first is methyl alcohol, IUPAC name methanol. Second compound, 3 carbon containing alcohol, common name N-propyl alcohol, and IUPAC name propane 1-ol, because at very first carbon from the 3 carbons of the propane, at first carbon we have alcohol or OH. So propane 1-ol. Third compound is again isopropyl alcohol. Okay, because the OH group is attached with a isopropyl group. So the IUPAC name will be propane 2-ol because at second carbon the OH group is attached. Next compound is 4 carbon containing alcohol. So common name N-butyl alcohol, and the IUPAC name butane 1-ol. The next compound is our secondary butyl alcohol. The common name is secondary butyl alcohol because we have a secondary alcohol. The OH is attaching with the carbon, which is then bonding with 2 other carbons. So this is a secondary alcohol, and 4 carbons are present in our parent chain. Common name secondary butyl alcohol, IUPAC name butane 2-ol. At second carbon, OH group attached. Next and the last compound is the 3 carbon containing alcohol, where the second carbon is substituted with methyl. So common name is isobutyl alcohol, and the IUPAC name is 2-methyl propane 1-ol. 3 carbon parent chain, so propane, and 2-methyl will be your substituent, which is your prefix. Word root is prop, ane is your primary suffix, E will be replaced by the secondary suffix, that is 1-ol, representing the position of the OH group. Continuing with this table, we have the compound, the alcohol, which is a tertiary alcohol, because you can clearly see the OH group is attaching with carbon, which is then bonding with 3 other carbons. So the common name is tertiary, or you can say tert butyl alcohol. Okay, so you have to put the alcohol in the end, and before that you have to put the alkyl name. And alkyl have 4 carbons, so that's why we are writing that it is a tert butyl, because it is a tertiary butyl. Tert butyl, and then for the OH, alcohol. But in the IUPAC name, you have to represent the positions of the groups of the substituents. For the you have to select the first of all parent chain, which we have selected, and after that we have done the numbering. The lowest possible number should be given to the OH carbon. So the numbering is done in the 3 carbon parent chain. So the substituent is 2-methyl, which is prefix. Then word root will be prop, 3 carbon parent chain. Then primary suffix, that is ane, and then secondary suffix, that is 2-ol. So at second carbon we have CH3 and OH both. Next compound is a special one because it contains 2 OH group, right? Which is binding or which is attaching with the adjacent carbons. So this is ethylene glycol. The common name is ethylene glycol, and the IUPAC name is ethane because 2 carbon chain. So ethane 1,2-diol. This is polyhydric alcohol. 2 hydroxy group is attached. So we write 1,2 for indicating the 2 OH group positions, and diol suffix for the presence of 2 OH groups. Okay. Note here that the E is retained in the name of alkane. Last compound is again having 3 number of OH groups. This is again a polyhydric alcohol. The common name of this compound is glycerol, and the IUPAC name is propane because 3 carbon chain is there. Propane, E is retained, and then we have to write the suffix 1,2,3-triol. Let's move to the nomenclature rules for phenol. Phenol. What is phenol? Phenol is the simplest hydroxyl derivative of benzene. That benzene over which OH group is attached and not any other, you can say, side group is attached, substituent is attached. So you can say that simplest hydroxyl derivative of benzene is phenol. In the IUPAC nomenclature, positions are indicated by the numbers. You can understand it, or you can understand this point by seeing this examples given. The first is the phenol. Common name and IUPAC name of this compound will be phenol. Then we have ocresol, or you can say orthocresol. IUPAC name is 2-methyl phenol. If you read both the name, common name and IUPAC name, then you can understand that actually the second position of benzene with respect to the OH group is actually the ortho position. Okay. Second position and sixth position after the numbering with respect to OH is ortho positions. Third and fifth position is actually meta positions, and fourth and first positions are para positions in the benzene ring. So this is orthocresol. At the second position carbon we have methyl group attached. Then we have metacresol, M representing meta position, because at meta position with respect to OH, methyl group is attached. The IUPAC name is 3-methyl phenol. The next compound we have is paracresol, because at para position or fourth carbon we have methyl group. IUPAC name is 4-methyl phenol. So you can see that in the IUPAC nomenclature, while writing the IUPAC name of the phenols, you have to indicate the position of phenol and along with the substituents, if present, they have to, or you can say position of them, you have to indicate by numbers. Let's take the example of, or let's take the case of dia-substituted phenols. So for the dia-substituted phenols, what does it mean dia-substituted? It means 2 substituents are present in the benzene ring. Then in that case, we use ortho, meta and para words for, you can say, labeling or for indicating the positions of the substituents. So ortho specifically used for 1 and 2 positions at which the substituents are present. Meta for 1 and 3 positions. Para for 1 and 4 positions. You can see these examples along with their common and IUPAC name. The first structure is actually catechol, or IUPAC name is benzene 1,2-diol. So we have two hydroxy groups. Okay, the substituents are OH only. So the OH group is attached at first and the second position. So with respect to first, the second position is ortho, right? So the common name is catechol and the IUPAC name is benzene first second diol 1,2-diol. Then we have resorcinol, benzene, or you can say IUPAC name is benzene 1,3-diol. At first and third carbon, we have OH groups. Then we have hydroquinone or quinol, which is also benzene 1,4-diol, because at first and fourth carbon, we have OH groups attached. Now let's talk about the nomenclature rules for ethers. So for the common name of ethers, the two alkyl or aryl groups are named alphabetically, followed by the word ether. So the general form of ether is ROR. The two R may or may not be same. Okay, it's better to say ROR prime. So O is binding with two R groups, which may or may not be same, and those two R groups may be alkyl or aryl or both. So the two alkyl or aryl groups around the oxygen are named alphabetically, and then you have to add the word ether for writing the common names of ethers. For example, we have this example, ethyl methyl ether. We have to write, so we have written the two alkyl groups name alphabetically, ethyl methyl, and then ether. You have to add the word ether. Second example, butyl ethyl ether. For the IUPAC name of the ethers, ethers are named as alkoxy-alkanes. Okay, alkoxy-alkanes. What does it mean? That means that we have two R groups, right? One you have to treat as parent chain or parent alkane, and that is dependent upon the number of carbon present in that alkyl group. So if the alkyl group is having larger number of carbons compared to the other alkyl group, then that larger alkyl group is chosen as the parent alkane. Then the smaller alkyl group along with the oxygen atom, you can say RO, is treated as an alkoxy substituent. That's why we are saying that the ethers are named as alkoxy-alkanes. So alkoxy is for the alkyl group, which is containing lesser number of carbons comparatively to the other alkyl group, and also containing one oxygen. So we treat them together and call it as alkoxy substituent, and the parent alkane will be the alkane containing larger carbon atoms. For example, we have these examples given. The first is methoxyethane. So C2H5 containing 2 carbons, CH3 containing 1 carbon. So methyl will be treated as alkoxy substituent, that is methoxy along with the oxygen, and the parent alkane will be ethane. So methoxyethane. Similarly, the second example, ethoxybutane, because butane having 4 carbon, ethoxy having 2 carbons. So ethoxy means 2 carbon chain along with oxygen, ethoxy substituent present at the first carbon of butane. So ethoxybutane. Let's see the table 7.2 showing the common and the IUPAC names of some ethers. So this table is similarly showing the compound, their common name and their IUPAC name. So the first compound is CH3OCH3. The common name is dimethyl ether. Both the R groups are same. And similarly, IUPAC name will be methoxymethane. So simple. Then we have the compound diethyl ether. Again, the two R groups are same, but we increase the number of carbon in both the groups. So diethyl ether, and the IUPAC name is ethoxyethane, because both are same, right? The next compound is methyl N-propyl ether. The common name is methyl N-propyl ether, because we have to write the name of two alkyl groups alphabetically and then add the word ether to it. The IUPAC name of it is 1-methoxy propane. The parent chain will be propane, and at the first position of the propane, first carbon of the propane, we have methoxy substituent. So 1-methoxy propane. Next compound is methyl phenyl ether. Okay, so for the common name, write the alkyl or aryl group's name alphabetically and then add the word ether to it. So methyl phenyl ether, or any sol, more general common name. IUPAC name for this is, so the larger carbon chain will be the parent chain, which is of course benzene. So the common name, IUPAC name will be methoxy benzene. Next compound is ethyl phenyl ether, or another name is phenitol, and the IUPAC name is ethoxy benzene. Next last compound is heptyl phenyl ether, because one of the alkyl group is heptyl containing 7 carbons and the other one is phenyl. IUPAC name is, we have to treat here the heptane chain as the parent chain because it is containing 7 number of carbon, which is greater than the benzene carbons, which is 6. So the IUPAC name will be 1-phenoxy heptane. Continuing on this table, we have next compound. The common name is methyl isopropyl ether, and the IUPAC name will be, the position of the methoxy substituent is at second carbon, so 2-methoxy propane. Next compound is phenyl isopentyl ether. So we have phenyl group and isopentyl group around the oxygen. Then ether we have to add in the common name. For the IUPAC name, numbering is done because you have this isopentyl, okay, where at the third position we have methyl group as a substituent, and at the first position we have benzene and oxygen. Okay, so the IUPAC name will be 3-methyl butoxy benzene, because benzene containing more carbon, it will be treated as parent chain. Okay, so 3-methyl butoxy and then benzene. Next compound is the compound in which 2 oxygens are present. So 2 ethers group are present. So it doesn't have common name, but the IUPAC name of it is 1,2-dimethoxy ethane, because parent chain will be 2 carbon chain, and at both the carbon we have 1 OCH3. So 1,2-dimethoxy ethane. Next compound is a cyclic compound, and you can see of course the cyclic compound or cyclic hexane will going to have greater carbon number, so it will be treated as parent chain. So it doesn't have common name known, but the IUPAC name of it is 2-ethoxy 1,1-dimethyl cyclohexane. So cyclohexane is your parent chain. Other than that, you have to add the name of substituents alphabetically. So at the second position you have ethoxy, then at the first position you have 2 methyls, so dimethyl, and then cyclohexane. Let's solve an example. Give the IUPAC names of the following compounds. So this is example 7.1, having 4 parts, and each part is containing a structure or a compound. You have to name them as per the IUPAC nomenclature. You have to give the IUPAC name of these compounds. Let's solve it. So let's solve for the first part of the question, giving this compound. So first what we have to do, we have to select the parent chain, which is the chain containing largest number of carbon in it, and also the carbon which is attaching with OH group. So you can see we have done the numbering. You have 5 numbers in the parent chain. The first carbon is attaching with OH group, giving the lowest possible number. Okay, so OH group carbon is giving the lowest possible number, and we have different substituents present, like the fourth carbon is with chlorine, the third carbon methyl, and second carbon is also methyl substituent. So here the parent chain is a pentane because 5 carbon chain is there. Substituents here are chlorine at the fourth position, methyl groups at the position second and third. So IUPAC name will be the prefix. Prefix will be the substituents along with their positions in the alphabetical order. So 4-chloro, 2,3-dimethyl, pent, that is your word root, ane, that is your primary suffix, e will be replaced by secondary suffix, 1, all. So this is the IUPAC name of this first compound. Then let's talk about the second compound. Again, we have to choose a parent chain because this is ether. Okay. So you have to choose the parent chain which is containing largest number of carbon atom. So the parent chain is propane, which is 3 carbon chain. And the substituent here is ethoxy, 2 carbon, along with oxygen, ethoxy, at position second of propane. So IUPAC name will be 2-ethoxy propane. Then for the third compound, this is a benzene, or you can say this is phenol, substituted phenol. Okay, we have done the numbering of the benzene ring. Lowest possible number is given to the carbon attaching with OH group. And then with respect to that, we have done the other numberings. So you can see that parent chain is actually phenol. Substituents here are methyl groups at the position 2 and 6. So IUPAC name will be 2,6-dimethyl phenol. Next compound, fourth compound, is again a nitro cyclo group, right, attaching with OC2H5. So this is also an ether. We have done the numbering. The parent chain will be, of course, cyclohexane because it is containing 6 number of carbons, and in the other alkyl group we have only 2 carbons. So parent chain is cyclohexane. The substituent is at the first position we have nitro group attached. At the second position we have ethoxy group present. So IUPAC name will be, in the alphabetical order, first of all the substituent name, 2-ethoxy, 1-nitro, and then the parent chain, that is cyclohexane. So 2-ethoxy, 1-nitro, cyclohexane will be the IUPAC name for the fourth compound. Now let's solve an Intext question 7.3. Question is, name the following compounds according to the IUPAC system. The similar thing you have to do. You have to name the given 5 compounds as per the IUPAC nomenclature. Let's solve for the first compound. Again, the simple thing, you have to choose the parent chain containing largest number of carbon. Then you have to number them. Okay. And the lowest possible number should be given to the carbon which is containing OH group. Okay. So the parent chain here is actually pentane, that is 5 carbon chain. We talk about the substituents, the CH3 whole twice, that means isopropyl. Isopropyl substituent is present at the second carbon of our parent chain. Similarly, CH2Cl chloromethyl substituent is present at position third of the parent chain. So IUPAC name will be 3-chloromethyl, 2-isopropyl, pentane, 1-all. Okay. Then comes our second compound. We have selected the parent chain here and done the numbering. So parent chain is hexane, 6 carbon chain. So parent chain is actually should contain the carbon which is attaching with OH. Substituent is CH3, that is methyl, at the positions 2 and 5. Also, the OH, the hydroxy group, is present at the position 1 and 3. So the IUPAC name will be 2,5-dimethyl hexane 1,3-diol. This is polyhydric alcohol. So E will be retained here of the parent alkene name. Okay. Then for our third compound, this is a, you can say, cyclohexane attaching with OH, cyclohexanol, and also attaching with bromine. So we have done the numbering, lowest possible number given to the carbon containing OH group. So the parent chain is cyclohexane, a 6-carbon cyclic chain. Substituent is the bromine, which is present at the third position, and the OH group, which is present at the first position of the carbon of the parent chain. So IUPAC name will be 3-bromocyclohexanol. Then for our fourth compound, which is containing a double bond. Okay. Now here, the parent chain should be chosen in which the double bond should be contained. Okay. And also the slowest possible number rule will also change according to the priority. So we give more priority to the carbon, or you can say we give more priority to the double bonded carbon. So lowest possible number should be given to the double bonded carbon, and then in the priority comes the hydroxy group. So parent chain here is hexene because it is a 6-carbon chain with a double bond. Substituents, so at the third carbon, at the third position, we have hydroxy group attached. So IUPAC name will be hex 1-ene 3-ol. Okay, hex 1-ene because at the first carbon we have double bond. We have to write the lowest number, double bonded carbon number in the name. So hex 1-ene 3-ol. For the fifth compound, which is again containing a double bond, here you have to do the numbering. So the numbering will be first carbon will be the carbon having OH group, and then 2, 3, 4. Okay. Now here if you see, the lowest number is 1, which is given to the OH group carbon, and then the second carbon is actually the double bonded carbon. Now you will say that double bonded carbon number is greater than the OH bonded carbon, because if you do the numbering in other way, like from the fourth, where you have written fourth, if you write the 1, 1, 2, 3, 4, then the OH group carbon will be getting 4 number, and the double bonded carbons will be getting 2 and 3 number, right? So in that case, what will happen? The OH group carbon will attain more greater number comparative to in this way of numbering, where the OH group carbon is actually attaining a lowest number, which is 1. So this will be preferable. Okay. Or you can say that at the first carbon we have OH, at the second carbon we have double bond. So 1 plus 2 is 3. But if you done the numbering in another way, 4 carbon will be your OH group carbon, and second carbon will be a double bonded carbon. So 4 plus 2 is 6, which is greater. So we will prefer this numbering. Here the parent chain is butene. Okay, butene. And the substituents, which we have given the lowest numbers, methyl, which is present at the third position carbon, bromine at the second position carbon, and OH at the first position carbon. So the IUPAC name will be 2-bromo 3-methyl but 2-ene 1-ol. Okay, 2-bromo 3-methyl in the alphabetical order, and then but 2-ene 1-ol. Now let's see this NCERT Exemplar Question number 9. The question is, IUPAC name of the compound is, we have given the image of the compound CH3 CH3 OCH3. You have to write the IUPAC name of this. From the given options you have to choose. The options are 1-methoxy 1-methyl ethane, 2-methoxy 2-methyl ethane, 2-methoxy propane, or isopropyl methyl ether. This question has correct answer as option C, that is 2-methoxypropane. Let's see how. So we have to first of all write the IUPAC name, remember. Okay. So you have to write the name in the IUPAC format, in the IUPAC nomenclature. So this is the compound containing OCH3, the alkyl group along with the oxygen. So this is a ether, right? So first of all, you have to select the parent chain by looking upon the number of carbons in both the alkyl groups. So our parent chain is actually the one containing 3 number of carbons, that is propyl. After numbering, we have chosen the parent chain is propane. And substituents, if we talk about, at the second carbon of our parent chain, we have methoxy group as a substituent. So the IUPAC name will be 2-methoxypropane. Hence, the correct option is option C, that is 2-methoxypropane. Okay. Let's look upon the summary. The points to remember from this lecture. First of all, we have talked about the alcohols. For the alcohols, the common names is based on the name of the alkyl group, plus you have to add an alcohol term to it. For the IUPAC name of alcohols, you have to remember some points that first of all, the suffix ol is used for the OH group while naming the IUPAC name of alcohol. You have to use diaol and triaol, etc. for the multiple OH groups present in your alcohol compound. Then you have a cycloprefix that you have to use in the alcohols, which is cyclic. For the phenols, we have seen that the chemical formula of a basic phenol is C6H5OH, which is phenol. Okay. We have we should use ortho for the 1 and 2 position, meta for 1 and 3 position, and para for 1 and 4 positions for the dia substituted phenol. For the ethers, which we have seen that the common name for ethers is, you have to write in this manner, that you have to first of all list the alkyl groups around the oxygen which is present in the alphabetical order, and then you have to write the word ether after it. For the IUPAC name of ethers, you have to name it in the format alkoxy alkanes. The larger group or the larger carbon group will be the parent alkane, and the smaller carbon group becomes the alkoxy substituent, which is OR. So alkyl along with the oxygen. This is what we have learned today, and these are the points that you have to remember from the today's lecture. Okay, thank you so much. That's all for today's chemistry session. Thank you.